Hello, I'm TJ Montserrat, and we will be discussing database and data storage options. So the objectives of this video is to define different database options or determine which database or data storage to use for a given requirement. So first things first, we'll go with the very first kind of database, which is SQL, or structured query language. So it is designed for managing data to hold that is held on a relational database management system, or RDBMS. Relational meaning that data are that the data within is related to each other. Usually the relation is um, via the use of foreign keys. So you will learn it more on your database courses. But this is when you want to use, if you want to use, or if you have data that are related to each other, and you want to have a strict schema. That means you have a structure of data that um, needs to be put on a table, or can be put in a table, um, which has a strict um, column number of columns. Then you will want to use RDBMS or SQL. Now, the idea also is, if you want to join tables in one query command, so that means you want to get data from any number of tables that are related to each other via a foreign key, and you want it to be outputted in one query command, then this is your uh, this is your um, setup in essence. Now, examples of these databases are MySQL, MariaDB, which is the open source version of MySQL, Postgres, Cassandra, Oracle DB, which is more of like the enterprise version. The Microsoft SQL is usually used by anyone who is using more of the Microsoft servers. And then SQLite, if you want to put local data to your application, mobile app on Android and iOS. Now, the next thing is NoSQL. So it's just um, you're not using the structured query language for this. And this part is for persistent saving. That means usually it uses the um, um, hard disk, or the data storage of your system. Now, if you don't need strict rules, you will want to use NoSQL. Uh, even if there is a relationship between the data, that means you are also using, let's say, the primary key of a collection to reference a particular data point on another in another collection, but you don't need to like show it in one go, that relationship. Then you can use NoSQL. It is also needed if your collection of data has an uneven number of properties. That means some has certain properties, some are not. So this is why they use the term collection rather than a table, because it's just a collection of objects. Sometimes the object is just a um, one key value pair inside that object, and the others are five, and so on and so forth. So it's also easy enough to use and set up. So the examples would be MongoDB, which is the um, sort of if you are familiar with um, uh, if you are familiar with single application setups right now, single page applications before. there was a strong move to use MongoDB because there is no need to like learn um, SQL. Actually, it was the main selling point before. No need to learn the SQL. You need to use standard libraries of your particular language to access the databases. Um, the thing is, those standard libraries are called object-oriented mapping. Um, uh, let's see. Object relationship object relational mapping, uh, in essence, using those libraries to um, use these databases without the need to learn how to um, do an SQL command. Eventually those ORMs are also being used in accessing um, uh, SQL databases. But yeah, for no SQL, you'll use ORMs usually. There's MongoDB, CouchDB. Then for cloud-based, if you are familiar with Google products, there's Firebase and then Firestore. You have DynamoDB for AWS. And if you're using your browser to put local data on your browser, you can use IndexedDB. Now, there is also NoSQL, which is memory based, and that is needed for quick storage for highly requested data. So, if you want low latency, or that means you want the data to be retrieved faster, then you would want to use NoSQL that is memory based. If you need to store user sessions on a highly scalable web application that tracks the user sessions, so you don't want to put your the knowledge of a user on just one single server, because if that user switches to another um, server that also serves the content, the server will not know that the user is still logged in. So you would want to put it on a different memory-based database instead of the memory of the server itself. Now, if you need key value type of storage where the value size is low, so this is also um, needed in essence. You would want to use a memory based storage if you want a key value type of storage. If you are also using WebSockets, which is an advanced form of protocol in uh, the web, where um, exchanging information is not API based but more of like a continuous connection between the browser and the server, or the application and the server, then you would need um, memory based uh, memory based storages, no SQL storages, for tracking all of those connections between the server. So it's also a kind of a user session. So there's only one example that I can think of for this one, which is Redis, which is usually the de facto memory-based no SQL server. Now, file storages. So we're going now from a structured database to unstructured data storage. Now, storing of any kind of file, may it be text or blob. Blob type, meaning it's binary. And then used for storing backup data of no SQL and SQL. So you can um, use file storages for this one, and used also for storing any unstructured data for processing before going to a structured storage for analytics. So examples of this are for Google, that's the GCS or Google Cloud Storage. You have AWS S3, and then the Azure storage. Lastly is the data warehouse, where if you want to put long term if you want to put data for long-term storage for data analytics, and where you want to put your large amounts of structured data for analysis and machine learning. That would need you can use GCP BigQuery for Google, AWS Redshift for AWS, and Azure Synapse Analytics. Um, so yeah, that is for our database and data storage options.